Okay, so today I have a little experiment to try. What I wanted to do was, I wanted to see if I could do a Weierstrass substitution on this integral right here. It makes sense with the 1 plus cosine x, but it's not too often that we do it when we have an x in the problem. Okay, so over here to the right, we have all of our formulas for the Weierstrass substitution. I've derived these in previous videos. I'll provide a link in the description if you don't know where this is coming from or how to get to some of these values. But one thing I'm going to need beyond everything over here is I'm going to need a value for this x right here. And what I'll do is we have this initial substitution, t equals tan x over 2. I can just rearrange this to get our x value. So coming down here, if I take arctan on both sides, then we have arctan of t is going to be equal to x over 2. And so I can just multiply in here by 2 on both sides. 2's cancel, and just like that, we've got a value for x. So we'll use this and just rewrite our integral with the substitution. So first our x is going to be 2 arctan of t, but I'll bring the 2 out front. Then in the denominator 1 plus cosine of x, I'm going to use this value right here. 1 minus t squared over 1 plus t squared, and then we need our value for dx. That's going to be a 2t. This is going to be 2t dt over the 1 plus t squared. And let me just kind of put parentheses so we can see what's happening, because we're going to need to distribute this into the denominator. Then from here, let's clean it up. I'm going to take a 2 out front of the integral. So now we're going to have a 4 in front. We'll have this as t arctan of t. Then distribute in 1 plus t squared to 1 is going to be just 1 plus t squared. When I distribute it in here, it's going to just cancel with the denominator of 1 plus t squared here. And this is going to give me a plus 1 minus t squared dt. T squareds are going to cancel here. I noticed that what we have here in the denominator, 1 plus 1, that's just going to be a 2. I also noticed a mistake. This is dx. This is just be a 2 right here. There's no 2t there. So that should just be a 2. And then we can get rid of this t right here and here. Sorry about that. So then dividing this 2 into the 4, we have just the integral of 2 times arctan of t dt. But now from here, this integral, what we can do is we can just do this and finish it off using integration by parts. So for integration by parts, let's just use the di method over here. We only have one function, so let me multiply by 1. So now that we have two things, and what I'll do is I'll differentiate arctan of t, and then we'll just integrate 1. Differentiating arctan, we're going to have just 1 over t squared plus 1. Integral here of 1, that's just going to be t. So then taking part of the solution on diagonals, I'll distribute in the 2. So we'll have 2t arctan of t. And then minus 2, this last row is going to be an integral. So this is going to be the integral of t over t squared plus 1 dt. But actually what I want to do is let's bring this 2 inside. Because if we do it like this, what you'll notice is the derivative of t squared plus 1 is just going to be 2t dt, so we're perfectly set up to integrate. I'll kind of skip the u substitution, and we can just do this on the fly. So bringing down this part, we're going to have 2t arctan of t. Doing this part, we're going to have minus natural log. I'm going to drop absolute value because t squared plus 1 is always positive, while natural log of t squared plus 1. And so now we just need to back substitute in order to finish it. So plugging in here, with t being tan x over 2, we're going to have 2 tan x over 2, then arctan of t, what's going to happen is we're going to have arctan of tan of x over 2, so we'll just write that as x over 2, and then here, natural log t squared plus 1, this is going to be tan squared x over 2 plus 1. 2's can cancel here. We have the identity here that tan squared plus 1 is going to be the same thing as secant squared. So putting this all together, for my final solution, we just have x tan x over 2 minus natural log secant squared x over 2, add a plus c, and that's it. Okay, so no surprise there, really. I think it made it a little bit longer, a little more complicated. I did this same problem in a previous video, same solution. That's good. It comes out pretty clean, but probably just kind of creating more work when you have x in the problem and do a Weierstrass substitution. Anyway, that's it for today. Thanks everyone for watching. Have a good day.